Hello friends, welcome back to the another video lecture of data structure subject. In today's video lecture we are going to discuss about threaded binary tree. Okay, so in linked list representation of our binary tree, the number of null links are actually more than known null pointers. Okay, so in this figure you can see that if we demonstrate this tree into linked list representation, then pointers of D means left pointer and right pointer will be null. Pointers of E left and right will be null. Pointers of F left and right will be null, and also right pointer of C will be null. So actually you can see here that you have 1, 2, 3 and 4 pointers, but they have 1, 2, 3, 4, 5, 6 and 7 null pointers. Okay, so this is the very crucial thing for representing our linked list representation of binary tree. So we can see that these are the totally vestige of our null pointers. Okay, so in above figure there are 7 null pointers and actual 5 pointers. In all there are 12 pointers. We can generalize that for any binary tree within node n, there will be n plus 1 null pointers and 2n total pointers. Okay, the objective here to make effective use of these null pointers. Main aim or main motto behind threaded binary tree is to make effective use of these null pointers. Okay, for that as a Perillis and C. Thornton jointly propose idea to make effective use of these null pointers. According to them, we are going to replace all the null pointer by appropriate pointer value called threads. Okay, so here binary tree with such pointer will called the threaded binary tree. Okay, so this is the concept behind the threaded binary tree. In memory representation of threaded binary tree, it is necessary to distinguish between a normal pointer and a thread. Okay, so mainly thread will be a last node with null pointers. Okay, so let's start with the threaded binary tree. So we have to choose from the two things. There are two threading type, one-way threading and two-way threading. Okay, so here our threading will occur to the in order traversal of tree. So for our threading, the in order traversal is must. We will do the procedure from the in order traversal of our tree. Now let's see threaded binary tree one way. So accordingly, in the one-way threading of T, a thread will appear in the right field of a node and will point to the next node in the in order traversal of tree. Okay, so here we will have concern with the only and only right field of a node. We do not have concern with the left field. Okay, and for that we will have to knowledge about in order traversal. Okay, so this is an example of threaded binary tree one way. Here we have tree means A, B, C, D, E, F, G, H, I, J, K, L. So here in that you can see that right pointer of D is null. Here right pointer of F is null, right pointer of E is null, right pointer of G is null, right pointer of L is null, and right pointer of J is null. In one way we will consider only and only right pointers. Here both pointers are null, but we will consider only and only right pointers for one way. So let's make its in order traversal. So for that tree, in order traversal will be look like D, B, F, E, A, G, C, L, J, H and K. So here in definition it says that a thread will appear in a right field of a node and will point to the next node in the in order traversal of tree. Okay, so if we check in this figure, D's right part is null, so it will show its next point in order traversal. Okay, so we will check D into our tree, or we can say our in order traversal. Its next point is B, so D will point to the B. Let's check for the F. So after F we will have E into in order traversal, so F will point to the E. In order traversal E, so E, after E we will have A, so E will point to the A node. Same as we can find for G, so let's check into after G we will have C, so G will point to the C node. After J it is H, so J will point to the H node. After L there is J, so L will point to the J into the traversal. So this is a binary tree, threaded binary tree into one way. You will have to remember that the right field of a node and will point to the next node in the in order traversal. Only right node, and you will have to point the next node into your in order traversal. So this will be the threaded binary tree one way. Now let's see threaded binary tree two way. So in two-way threading of tree, a thread will also appear in the left field of a node and will point to the preceding node in the in order traversal of tree. Furthermore, the left point of the first node and the right node of the last node in order traversal of T will contain the null value when T does not have a header node. Okay, so for that two way we will have to keep in mind these two things. Right pointer will check next node of in order traversal, and left node will check previous node of in order traversal. Okay, again right node is null, then it will point to the next node of in order traversal. If our left pointer is null, then it will join with the previous node of in order traversal. Okay, so this is the tree. In that tree, here we have D, and left and right both are null. So for leftmost node and rightmost node, there will be leftmost node's left pointer and lastmost node's right pointer will be always null. Okay, for that we will have a solution that we will discuss into next slides, but let's consider the case in which our left node is null. Then we will point to the previous node in order traversal. Okay, so if our F do not have any left child, means its left part is null, then it will point to the previous node in its in order traversal. So let's check what is the previous node of F in its or we can say in order traversal. So here before F we will have B, so F will point to the B. For G, let's check G's previous node is A, so from the left G will point to the A. Let's check for the L. So if L do not have any left child, then L will point to the C. So here L is point to the C. Let's check for the K. So previous node of K is H, then it will point to the H. So this is the two-way threaded binary tree. Here answer for leftmost node and rightmost node. Here our explanation says your rightmost node, or we can say right child, is null, then it will point to the next node into in order traversal. So if K will point to its next node, then here in order traversal no node available into next of K. Same case for the D. D will have its previous node into in order traversal. So if we want to point previous node of D, then no node is available into previous of D. So there will be null values into leftmost nodes left side and rightmost nodes right side. Okay, so this is two-way threaded binary tree. Again, two-way threading has left pointer of first node and right pointer of the last node will contain the null value when T will point to the header node is called two-way threaded with header node threaded binary tree. Okay, so for that solution we will have a node with the header node and it will be known as the two-way threading with header node. Okay, so this is the figure. This is the header node of this tree. Okay, so here first node's left child and last node's right child will point to the header node. In this example, link representation of threading binary tree is here. Inner traversal of the tree is GFBADCA. Okay, so this is the figure for finding a threaded binary tree that will contain mainly the 5 fields. 3 fields are already we have discussed in our linked list representation. Middle field will be the data. In right side we will have the address of right child, and in left side we will have the address of left child. 2 more fields are added here. In this field we will have the right thread address and right thread flag, and in this field we will have the left thread flag. There can be a value of 1 and 0 form only. This field can be filled by 1 and 0 only. If our left thread field is filled with 1, then it indicates left child of P is a thread pointer, means it will have the null value into its left child. If our thread P of left child is 0, means if we indicate it with 0, then that will be the normal node. They do not have any they will have a left child. Okay, in right side we will discuss that same case at the left child. If we indicate it with 1, then there will be no node, it will be null pointer here, and if we indicate it with 0, then there will be a point. In case of null pointer we will indicate with the 1, and if we have a node available at there, then we will indicate it with the 0. Okay, so this is the representation of the tree. Here we will have first node A and it have left and right both child here, so we will indicate with the 0. Let's consider with the B. B have left child, so left thread will be 0, but it do not have right child, so right thread part will be 1. We discuss for C. C have left and right both child, so we will put 0 on the left thread and right thread part. Let's discuss for F. So F have left child, so we will put 0 on the left thread part, but it do not have right child, so we will put 1 on the side of right thread part. Here D do not have any child, so we will put 1 on both sides. E do not have any child, so we will put 1 on the both sides. Here G also do not have any child, so we will put 1 on the both sides. Other things which are same as our two-way threaded or one-way threaded binary tree. Okay, so this is the threaded binary tree with the our data parts and also the flags of left thread and right thread. So this will be the most IMP question for your examination, so this is very important for your this topic. Now let's discuss about advantages of threaded binary tree. So threaded binary tree have numerous advantages over non-threaded binary tree. They are listed as below. The traversal operation is more faster than that of its unthreaded version, because with threaded binary tree non-recursive implementation is possible, which can run faster and does not require the botheration of stack management. Second advantage, the more understand with the threaded binary tree, we can efficiently determine the predecessor and successor node starting from any node. In case of unthreaded binary tree, however, this task is more time consuming and difficult. For this case, a stack is required to provide upward pointing information in tree, whereas in threaded binary tree, without having to include the overhead of using stack, the same can be carried out with the threads. Let's discuss third advantage of it. Any node can be accessible from any other node. Threads are usually more to upward, whereas links are downward. Thus, in a threaded tree, one can move in their direction and nodes are in fact circularly linked. This is not possible in unthreaded counterpart, because there we can move only in downward direction starting from root. Insertion into deletion from a thread tree are although time consuming operation, but they are very easy to implement. Let's discuss disadvantages of the threaded binary tree. Insertion and deletion from a threaded tree are very time consuming operation compared to non-threaded binary tree. This tree requires additional bit to identify the threaded links. Okay, so this is the threaded binary tree, advantages of it and disadvantages of it. If you like this video, then like, comment and subscribe. Also share it with your friends. Thank you, friends.